y value is its height in feet, can be modeled by this function, because this is literally the path of a shot put. All right, so here is the function. And x is the horizontal distance, y is the height. Let's see what the questions are. What is the maximum height of the shot? All right, the max height. And how far from its release point does this occur? The max height will be k, and how far will be h. In other words, this point here, I don't know that I'm actually finding it, is, go away, hk. The height is k, how far is h. Then it wants the shot's maximum horizontal distance. That'll be right here. That is an x-intercept. And from what height was the shot released? That's right there. And that's the y-intercept. I can get all of that information from my grapher. So I will go to my grapher and go to my y equals, clear this one out, and type in little negative sign 0.02 x squared plus 1.2 x plus 6.4. All right, I can use the x's and y's here to mimic this window. It is going from 0 to 100 and from 0 to 50. Okay, so graph. All right, I have a simulation of what this is. The first question says, what is the maximum height and how far from the original point? So the maximum height is here. How far from here? That is also part of the vertex. So I'm going to do second of the trace key, which is calc. Number 4 is maximum. I need to be on the left side first. You have to do a left bound first. Enter. Now go through that max. Enter. You can see it is sandwiched between those two. Hit enter a third time, and this would become 30, 24.4. So let me write that down. It is 30, 24.4. All right, the maximum height is the 24.4, which occurs at 30 feet from the point of release. What is the shot's maximum horizontal distance? All right, that's my x-intercept. Let's go back to, and I'm going to put in, go down, put in 0. There it is. Second, calc, intersect, which is number 5. Let's head over to it. You don't have to do left and right, you just have to get close and hit enter, enter, enter. It says to round the x to the nearest tenth. This is rather small, but it is 64.9. 64.9 feet. From what height was the shot released? That is this. which is the y-intercept. We can get the y-intercept by going to table, putting in 0, which it already has a 0, and this is 6.4. It is so nice that all of that information can come from the grapher. And so at the conclusion, I will try to talk about a summary of some of this. All right, let's go to number 11. A ball is thrown upward and outward from the height of 6 feet. The height of the ball in feet can be modeled by, here's an equation. It is negative, it is going down, so one of these is right. Question, what is the maximum height of the ball and how far from where it was thrown does this occur? That is a question asking about the vertex. How far does the ball travel horizontally before hitting the ground? That is the second of the x-intercepts. And then we'll pick the graph, and it does follow a parabolic curve. All right, so let's go to our function, our grapher. Go to y equals, clear this out, type in negative 0.2x squared plus 2.1x plus 6. I don't know if I've got a decent window. I'm going to go back to a zoom 6. I could have looked at all of these, and I guess I will. They all go 0 to 25 and 0 to 25. So when you've been given a graph that you're working from in MyMathLab, you can mimic the window. All right, first question. It says, what is the maximum height and from where was it thrown? So that's your vertex. Second, calc. It's a maximum in this case. I have to get to the left side of the maximum. Remember, it's prompted you saying left bound. There we go. Right bound. Enter. All right, 5.25 and 11.5 because it says to round to the nearest 10th. So the maximum height is 11.5 and it occurs at 5.3. So let's look again. 5.3, if we round it to tenths, maximum height 11.5. Okay, then it wants to know about how far does it go before it hits the ground, and that's the y-intercept. So second of the trace, which is calc, number 5, intersect. And remember, you can toggle and travel on the x-axis if you want. You're just trying to get very close to that. Enter, enter, enter. Once again, it says round to the nearest 10th as needed, so that will be 12.8. Oops. And which of these looks like our graph? All right, now its maximum was only 11. We don't even need to look at that. Its maximum was 11.5. That's occurring here. And 12.8 here. This is it. All right, we have a few more application problems. And it says, among all pairs of numbers whose sum is 14, find a pair whose product is as large as possible. And what is the maximum product? All right. Now, we're not going to use x and y as the two numbers. We're going to use as the two numbers, x is the first number, and 14 minus x is the second number. This is one technique when two numbers add up to be 14. One of them is x, one of them is 14 minus x. And you could see that if one of them was 4, the other one would be 14 minus 4, which is 10. Okay, so this is going to be helpful to you. Now, the product, and I'm just going to call it product, or maybe I'll call it P of x, is x times 14 minus x. That's 14x minus x squared. I could write it as negative x squared plus 14x, and then we know that means plus 0. All right, it wants to know two things. The two pair of numbers, well, let's go to, believe it or not, let's go to the y equals. Let's clear this out. Put in negative variable x squared plus 14x, and just do a zoom 6. And we don't have a very good window. So I will do a zoom. No, I won't do a zoom. I'll do a window. I need to change x max to about, I don't know, 20. And y max, it didn't seem to get close. I'm going to put about, I'm going to put 100 in there. All right, this is something that we really haven't seen before, but the vertex is going to give us an HK. The H, remember, is X. K is Y, but in this problem, I'm not calling it Y, I'm calling it P of X. Right here. I didn't call it Y, I called it P of X. So when I get that vertex, I'm going to have the X number, and then I can find the second number, and I'm going to have the highest product you can get. So let's go back to the grapher. Second of calc, I want the maximum. That looks like a good left spot. Pass through it. There's the right spot, enter. 6.99999, that rounds to 7. So this is the point 7, comma 49. Whoops. 749. So it is 7, comma 49. Now those are not the two numbers. It is the number x and the product. So x is 7. Then you can do this. 14 minus x is 14 minus 7, which is 7. The two numbers are 7 and 7. The largest product, this is the product, 49. So I'm supposed to just put 7 and 7, and the maximum product is 49. All right, I know that's perhaps a little unusual. let's look at number 13. This is quite a long video. This says, Farmer Ed has 150 meters of fencing and wants to enclose a rectangular plot that borders a river. That means that he only has 3 sides that he needs to fence. He does not fence the side along the river. Find the length and width of the plot that will maximize the area. Okay. Now, to do this one, I'm going to draw another rectangle. And I'm going to say X and X. Now, we're not going to enclose this. I need to get a representation for this side. I know that the total of all 3 sides is 150 meters. I'm going to take off an X, and I'm going to take off another X, and whatever's left over is this side. So this is 150 minus 2X. That is this side. Now they did it right here, X, 150 minus 2X. But I wanted you to know why. He has 150 meters all the way around. If he comes out this far, and we don't know how far, but it's X, then he has how much left over for this side. It's the total minus what he used up. Now, in this, I want to know the dimensions and the maximum area. This area, it is length times width. So it is X times 150 minus 2X. This would be like the width. This would be like the length. All right. I want to maximize the Y component. So I will type this into my Y1 is X. Well, I'll go ahead and multiply it out. I don't have to. It is 150x minus 2x squared. All right, go to your grapher. Y equals, clear, 150x minus 2x squared. I don't know what window I'm in. I'll just look. I'm certainly not in a good window. I saw it going up. I need to go up a lot in Y max, and I need to go over a lot in X max. So window, X max, I'm going to go out to 100. And Y max, I don't know. It's going to be an area. Let's put 500. Okay, now I could turn off my Y equals 0. That's what's plotting down here. All right, my Y max is not anywhere close to enough. What if I tried 1,000? No, not close. Here's something you can do. You can go to Trace. Now you can't even see it's tracing in the middle of the screen. The middle X is getting traced, but I see that it's 2700. So that's why, whoops, I'm not seeing anything. I'm going to go to Y max and make it be 3000. That ought to be closer. Very nice. All right. The max. The max will be an X, well, you can call it H, K. That's the max, that's a vertex. In our case, it will be an X. Oh, here's X. That'll be a dimension. and then it will be the maximum area, because y we're calling area. You have to get used to this ordered pair could represent the vertex HK. It could be just a plain old point, XY. But since Y is representing area, it's X area. All right, so let's go back to the grapher and do second calc maximum. Get to the left. Enter. Go to the right. Enter. Enter. All right, looks like it is 37.5, and so let's do the ordered pair. The vertex, well, I can do it down here. It is 37.5, comma, 2,812.5. Let's double check that. Okay. Now let's see about answering the questions. I have this, but what do I have? This is the width. It's X. Okay. The picture told me to use X there. Oh my goodness. It is 37.5. The other one, I don't know. Let's see. 150 minus 2x. That's 150 minus 2 times 37.5. That is 150 minus 75, which is 75. So right now, here's what I've got. I've got that this side is 37.5, which means this side is 37.5. I just simply plugged in 37.5, and I got that this side is 75. The largest area is right here. It's 2812.5. So the vertex occurs at the maximum, but the coordinates of the maximum are whatever you've chosen for x to be, which in this problem was the width, and whatever the function represents, which is a. All right, last one. In this one, we don't have a river. We have a rectangle, and it says that Sienna has 520 yards of fencing to enclose a rectangular region, and you want to make it as big as possible. So I'm going to call X the width, and I need an expression for length. Okay, 520 minus those two X's will give me what I have to put here and here, because I don't have a river. So for one of those sides, I need to divide it by 2. That gives me 260 minus X. 2 goes into 520 260 times, 2 goes into 2x, x times. So this is 260 minus x. So this is the width, this is the length. They have to be in terms of variable x. So the area as a function of x is x times 260 minus x, length times width. It is 260x minus x squared. If I want to maximize the area, this is a quadratic. Maximum occurs at the vertex. So I will put in x, 260x minus x squared. And I'm going to go ahead and eliminate that x equals 0 because I don't need it. Let's just see. This was the leftover window. Not good. All right, this is really big. So I'm going to change my x max to about I'll make it about 300. And I'm going to make this be about 5,000. Sometimes this is just guessing. All right, I guessed okay on the x, but I need to go up a lot further. Let's do trace again. Oh, 16,675 in the middle. So I'm going to go to window and I'm going to make it be about 20,000. That little trace trick helps. Whoops. Come back. Second, calc, maximum, enter, enter, enter. So this would become 130, and this would be 16,900. So I'll write those numbers down. So I have a vertex which is 130, 16,900. What is this? This is x, which is the width. This is not the length. This is the max area. How do I find the length? That is the one that is, the length is 260 minus x. It is 260 minus 130, which is 130. It turns out that when you're making a rectangle, all four sides, and you want it to have the maximum area, it's always going to be a square. So the length is 130, the width is 130, the maximum area is 16,900. So 130, 130, max area is the y component of the vertex, 16,900. Okay, there's a lot involved in that. Be sure to use your formula packet if you need to always be able to find the vertex, the x-intercepts, and the y-intercept. Okay.